What is up, everyone? Huge reception on the Pedal Builder Reacts videos, and I really appreciate all of your comments and feedback on that. Selfishly, here today, I have a plug for my analog delay, and I'm going to kind of go through the ins and outs of it and my kind of thought process when I designed this circuit board and all the guts that go into it. I did do a batch recently, and it sold out within an hour and a half. So that's incredible. Thank you all if you purchase one. If you want one, you can go on my website, thetonegeek.com, and you can sign up for in-stock notifications. And I also post on social media like when I'm going to drop new ones, typically. Maybe I'll surprise everyone someday, and if you're a website follower, then you get the advantage. But anyway, this is my LOMARK, and the name actually comes from one of John Mayer's pedals, which is his AP2 version of the Aquapus. So this is a clone of a Aquapus, specifically the original, not the AP1 that had a different internals inside, basically all the transistors here, and I actually have a real one. But that's not this version. This is the AP2. This is the one that followed, and it's the one that John used in the John Mayer Trio. It's the one he used on Where the Light Is, as far as everyone's knowledge. And you'll notice that if you look at pictures of those shows, the sticker on here says LOMARK. And I don't know what it means. I don't know what it means at all. But I thought it would be kind of a cool way to sort of identify what version of the Aquapus this is. It is using the original MN3005 chip, and I'll go into that in a little bit. So, aesthetics, I use alpha. On this run, I'm using alpha pots, or alpha stomp switches, super rugged, basically the industrial standard for stomp boxes. Sometimes, I'm using these for now. They are a little hard to push down, which actually, I don't know. It seems like most people like the mechanics of, being able to put your foot on it and then just go just a little bit further. You can know with your foot if it's engaged or disengaged. I find that the really soft switches are just so easy to push. You don't really get that feedback with your foot. That's my preference. Some people just like to come over and like bam and then done. That's cool too. That's not for me. I try to put in what I think is the best approach on these things. But anyway, pots, all alpha pots, high torque. Kind of, if you watch my other videos, I like these a lot. They stay in place. These are Davy molding knobs, kind of just like the original Aquapus, the feedback one. So you got the two big Davy molding on the side and then the one smaller one in the middle. Because of the footprint, I thought this looked pretty sharp. The graphics are pretty similar to original Aquapus. The layout is the same. You get more delay when you turn to the right. You get more mix when you turn to the right. The big difference that I did in this design is that this mix pot, if you are a John Mayer fan, and Brad Paisley as well, used like a very minimal slapback. So more or less the delay is over here, feedback is all the way down, and then the mix is pretty low just to get like a small slapback. Something that sits a little bit above your reverb, because you'll notice the reverb sort of messes, or it reduces the amount of the effect of the delay because it gets lost in the reverb. So you kind of have to go up a little bit. But it is kind of hard to fine-tune so low down here what the right amount is. I mean, literally, it's the difference between this and this. So what I did, and that is using the original uses linear taper, which means that if it starts off, I believe these are 50K, like here, it's very predictable. Halfway, 50K is 25K. Now this is logarithmic, so it's more or less like a volume knob, where there's like small increments, small increments, small increments, and then it starts you hear the bigger difference way over here versus, somewhere over here. So when you see like the knobs maybe on John or Brad's pedal board, like down here on this taper, you're going to get like, you can find your sweet spot even somewhere up and around here. So yeah, it's way better. You're going to really tell a difference when you try to find the sweet spot in that delay. Compared to the touchy, I think a lot of people use like the Make 2 version, the reissue, using the other chip, the MN3005 delay, which has a lower headroom, blah, blah, blah. Okay, so inside, here are the guts of the inside. I like the stereo jacks at the top, so there they are. There's extra sort of fingers or things touching the jack so it holds it in place. This thing is not going to pop out very easily, sometimes at all. Oh, okay, there we go. Something I started to do, which I like, is putting this little ground bus here, so everything is coming back into a single ground point, which is this ground bus. So the power ground goes up to this ground bus, kind of like what I do with my guitar amplifiers. You got the jacks, which are already, see, you got the star washer here, or the internal tooth lock washer. So these jacks are really biting in for the ground to the chassis. And then you have this ground bus. So, and that's where the circuit board attaches to. So here is where the circuit board attaches to, and here's where the ground is for the jacks, and here's where the ground is for the power jack, which means that this is, in theory, going to prevent any sort of ground loops and lowest noise, blah, blah, blah. All right, you're going to notice kind of these cool little capacitors all in a row. These are blue. You're going to notice that those are blue, and that means that they're solid polymer. You're going to find these in like high-end video graphics cards, anywhere there's a lot of heat, because it's a solid polymer. They're rated basically by how much the heat is in the environment and how long in that heat that this capacitor can last for, and that dictates how, the expected lifespan of here. So given that these pedals are likely just in room temperature, these solid polymer will last basically probably longer than you will play guitar, and it's going to last way longer than the original Aquapus. Another advantage here is that it's really, really quiet, meaning that they're, as far as like ripple goes in the power supply, they're very low ESR, extremely low ESR actually. So you'll notice that sometimes to make up for electrolytics, you're going to see like 100 nanofarad little WEMAs like this, or film caps, to kind of take that top edge of the ripple out of the DC power supplies, but that's not required here. So instead of adding a bunch of 100 ohm or 100 nanofarad capacitors to reduce the ripple on the power supply, just choosing a high quality electrolytic, or in this case it's a solid polymer, will automagically do that for you. Trim pots. So the original Aquapus uses these trim pots that are basically more or less like one of these pots. There's the lowest, and then you go up to your highest, and then you're sort of trying to figure out where you need to calibrate this thing. I'm not happy with that. I want fine tuning. So these trim pots are actually 25 turns. So you see this little thing here. So when I'm calibrating each and every one of these, there's 25 turns that you can go. You just keep on going and going and going, and then you can go in reverse, keep on going and going and going, up to 25 times, of course, to really fine tune that clock frequency, or the bias. I find this very important, because I'm pretty picky. I want the best calibration. If I'm going to go do and calibrate it, and I have an expensive oscilloscope now and function generator, I want the calibration to be perfect. So what I did do, you see the clock frequency here. I have an original Aquapus, and I've actually had access to 2 of them, and I measured the clock frequency, and each and every one of these pedals, I am setting the clock frequency exactly like the original Aquapus that I had access to, which is right around 6.27 kilohertz. Giving away all the secrets here. What else can I talk about? All right, so for layout design, power supply, basically I had all the power come in. Here's the crowbar for reverse polarity protection. Kind of going down the line here. The power supply, giving the power supply to across all the chips and anywhere that power is required, like on these MPSA 18. So these are, I believe, Fairchild MPSA 18 per original. These resistors are, well, they're, surface mount, of course, but they're all the same values and all the same values across the board. The things that matter here, so you're going to notice that there's a bunch of wires and they kind of come off to the side, and then this one kind of goes under the board. This is my input, and it runs under the board, and if you look inside the real Aquapus, there is a coax cable from the input to the foot switch here, and that's to eliminate any crosstalk from over here. This chip generates a clock frequency for the bucket brigade chip that is in the audio spectrum, and if this wire is too close over here, you're going to have that noise be introduced into the input, and that's not good, and you're going to hear like a 10 kilohertz whine or whatever the frequency that chip is operating at, which dictates the bucket brigade delay. That'll be introduced into your signal chain. Not good. One way to prevent that, and for me, assembly-wise, it's a lot easier, is just to physically put that cable or that connection as far away from this side of the board as possible. So I did actually design the layout of this circuit board in a way that all of the signals or all the clock frequency radiation is kind of in this corner as far as it goes, and no signals. This is a ground pour, and so there's no linear crosstalk on the signals. And here is sort of like a circuit board underneath. Oh, here's a fun thing. Aquapus. Here's the meme cat, since it's an Aquapus cat. This is what you see under your board. Not many people are going to see that, but that's what it looks like. And you can see all the connections. Because of better assembly, here are ground vias that sort of help keep the side of the circuit board all together. I don't know. That's way overkill for these type of applications, but that's as far, I keep on pushing these circuit boards to be as robust as I can. I found a source for original, let's see if I can get close, Phillips companders, which is basically reducing the hiss and expansion and compression of the signals in the regen and such like that. So here is something kind of neat, and I got this inspiration from the Aquapus, the third make of it. The first signal that comes in from the in kind of goes through this little tiny network, but before it hits this transistor, I have it going through a polyester film, and this is what they do in the Make 3 Aquapus, and I thought I would implement that in this design as well, because it makes sense that this is more or less in theory a high quality polyester. You might hear me talk about polyester caps a lot. Instead of going through all these other capacitors of not really lower quality, but not as held in the highest regard. I preserve the signal as much as I can before hitting this transistor. And one way I did that was using this WEMA polyester cap. I believe this is a 47 nanofarad before it goes into the rest of the circuit. And then that, I think, I don't know why, but I feel when I play with this pedal over my Aquapus, my original, and even my AP2, I don't know, there's something about this one that just feels better. It sounds exactly the same, but this one feels better. And I don't know if that's because of the low noise floor of everything else, but I don't know. It just feels better, and I hope you find the same. As far as chips, I offer, as long as I have inventory, two options. This is a less expensive version, which is the X Vive. Hopefully I'm pronouncing that correctly. Reissue of the Panasonic. Here's a real Panasonic clock generator. The original op amp that's used over here. When I bias, and here's the Panasonic remix that I'm using, and I admit this looks a little suspect, but when I was biasing, because I have a real DoD, I don't think it's within arm's reach right now, Proformer 858, which has, from the 80s, which has a MN3005 Panasonic. And I've been using that, and I've been plugging it into each and every one of these pedals just to make sure the original chip sounds like, you know, anything I come across, including the X Vive. And the biggest thing that I can tell, and I don't know why, but these bias a little differently than the X Vive. And the X Vive chips a little bit more forgiving when it comes to biasing, which means I can slam in a little bit higher of a voltage incoming signal, and it handles it just a little bit more forgiving when I adjust the trim pot. These are consistent with what I see on the vintage Panasonic chips, which gives me some confidence that maybe these are just relabeled Panasonic just to make them cleaner or something. I'm not sure. But at some point, I need to trust the manufacturer and my suppliers for these chips. You can see that there's a genuine sticker underneath that signifies that it's genuine, based from the manufacturer or from my supplier. At some point, I need to trust them. And I did my own round of testing, and it seems to line up with my original chips that I have here, confirmed original because they're from the 80s. So I'm feeling good about that. Here's my output wire. You're going to see the same sort of thing. It comes way over here, but this time it's on top of the circuit board, and that's to reduce any crosstalk of the noise that's sort of radiating in this area for that chip. So yeah, I think that's everything I can talk about here. Alpha pots, high torque, black enclosure. Sort of my thing. I've been using and I've been loving this solder. It's kind of audio grade. I don't know. It's really shiny, and you're gonna see like some resin that is not conductive. And it's sort of a pain to clean all these boards. And it can get expensive with these cleaners, such as this cleaning supply. But because that flux is not capacitance, you know, it basically doesn't have any electrical properties, it's okay to leave on there. So that's another reason why I chose it. It's quicker manufacturing, which means more people get to enjoy these pedals. Because I can make more of them quicker in my limited amount of time between it all. The last thing I want to talk about is some people say the tone is in the LED. So now I'm going to sort of take my phone out and show you that I chose from a bunch of LEDs to get one that is like a cyan color that matches the original Aquapus. So it's a little tiny subtle detail that I hope everyone appreciates how much time and the expense of finding that LED that matches kind of that enclosure color. So yeah, I'm really proud of this one. hopefully anyone that wants one of these can get one. There we go. And stay tuned for more cool Pedal Builder Reacts videos.